I'm going to talk a little bit about our previous DNSSEC implementation, because last Monday we actually put OpenDNSSEC in production in .se. We haven't really been official about that externally, but we're going to publish a press release about that next week, I think. So this is how we did up until now. Our entire production system consists of our provisioning system with a customer database here. I'll go into that, but when we have produced a zone file, it's distributed to a number of distribution points, and then we have a number of name servers at the bottom here that actually answers a lot of DNS queries. When we first deployed DNSSEC, we actually made use of our two distribution points, where one of the distribution points received a signed zone, and one still had the unsigned zone. So each name server could pick the new DNSSEC signed zone from the DNSSEC distribution point, one at a time. And that way we could roll out the signed zone in a controlled fashion, just similar as to what root currently is doing. They have one large root name server still that doesn't have the signed zone, the J root server. That's going to be the last one. Then all the root servers have a signed zone out there. And that's going to happen on the 5th of May. So if everything breaks on the 5th of May, you know that kind of be the cause. So what we have here is that we have a customer database with all the customer information that also contains the name server information that we are publishing. So every 2 hours we gather that name server information into a zone file using the zone file generator machine. And before DNSSEC, we just sent the zone file out to the distribution points and then to the name servers. When we added DNSSEC, we just hijacked the chain and sent this zone file to the zone signer machine instead. So we built an entire new DNSSEC environment with a KSK stored on the smart card and the zone signing key. We also had a separate key generator machine where you plug this in, and that machine has never been connected to the internet in order to provide for a higher security. And we had a hardware random number generator. So each time we generated a new key set, we did it on the key generator machine and then put the key set on the zone signer machine that did the zone signing. So the communication between the zone file generator machine and the zone signer is done using SSH. And this is sort of a big difference between a large name server operated that has multiple zones, because we only have one zone that's quite large that we need to sign. So after we send it back the zone to the zone file generator, we run a large number of checks to see that the zone signer machine hasn't done any damage to the actual content of the zone. And then it's sent out to these distribution points just as normal. So the key generator machines it has never been plugged into a network, which caused a lot of problems when we actually installed machines with all the software that we needed. And then we have the key signing key on the smart card. So how it works is that each month when we generate new keys, we generate a new zone signing key each month and a new KSK each year. So each month we have to sign, we have to put a signature over the DNS key record using the smart card. So we have to produce the smart card and plug all that equipment into the key generator machine. And we produce the random numbers using the random number generator to produce the new zone signing key. We make the signatures and then we transfer the keys over to the zone signing machine using the USB memory card. So we only put the zone signing key on the zone signing machine. And the reason we did this did this way that we looked at HSMs, which actually is this kind of thing. An HSM is a hardware security module, which banks typically use when they handle certificates and stuff like that. But those HSMs were really expensive at that time, so we chose to have the cheapest possible HSM, which is a smart card, which typically contains one key and produces a very small number of signatures per second. So we only use it that way as well. This gives us the possibility of actually having the split responsibility that Anne-Marie talked about. She talked about security officers and system administrators. Typically, to just administer DNS, you just have a system administrator who produces his own file, and then you're done. When we designed this system, we decided that we really wanted to have a high security regarding the keys that we handle. So in order to have that kind of security, we don't let anybody control the key itself. The key is typically locked into a security box that is stored in the computer room. So the security officer cannot access this equipment without being let into the server room by the system administrator who has the access. And the system administrator cannot get to this equipment by himself. So that way you have to be two persons at the same time to actually generate signatures with the KSK and produce new keys. And the system administrator can log into the system and actually produce the new key and has access to all the systems. Whereas the security officer has access to everything to actually create the key and stuff like that. So, and I think root has, besides these two roles, also have a third role where you have an observer who just looks at this and makes sure that everything is done the correct way, and then put the signatures on the paper and just say things worked exactly as documented this time. In a smaller environment, you just mix all these roles together, so you don't have to care about it really. But it's much easier to generate a secure system from the beginning than to increase the security afterwards. And this is basically how it looks like. We have the smart card in the smart card reader, which we produce to and insert these things into the server when we generate a new key. When we sign the zone, we have a very large zone. I think today it has about 2 million records or so. This is data from, I think, 2008. So what we see here is that you start to fetch the zone from the zone generator machine. And then you merge in the keys that we have. We load the zone, just make sure that it works, and merge in the stuff. And here you see that it starts to keep valid signatures. What we do in .se is that we look at each signature in the zone file and determine if it's too old, because this machine is quite slow. So we want to make as few signatures each time as possible. So we actually keep signatures, because we do this every 2 hours. We can actually make a signature that our policy says that our signatures should last for about 7 days or so. But they must not be older than 4 days. So we keep all the signatures that are valid for at least 4 days. So for every signature that's too old, we drop them, and that's about 31,000 in this example. And then there's 59 signatures that we cannot match with the record that exists. So we drop those because there are lots of changes in the SSO. And then you can see that we have about 31,000 signatures that has been newly created. That is, they have a validity of 7 days now. And then we send back the zone delivery done. So that's the work of the signer. for a small zone, you just renew all the signatures every time. When you have a very large zone, you also want to decrease the time it takes to deliver it to all the name servers. We use IXFR today, which is an incremental transfer. You only send out the differences between the different zone files. That's also why another reason why you want to keep old signatures, so that each time the IXFR is not very large. We also have that functionality on OpenDNSSEC for very large zones, and you don't have to care about this if you run a large number of small zones. We have looked and played around with a lot of different types of user interfaces. This was the first prototype we used to actually let child zones to publish their keys in the SE zone. So it was called Keyman for Key Management prototype. And what it did when you logged into the user interface as a manager for a certain domain, the web interface queried the name servers for any keys that you had in that domain from the name servers. And then it asked the user, what keys do you want to publish? This is what I currently have in my database. And these are the keys that you have from the DNS. And then you just choose which keys to publish. And the hard thing about user interface is that you must actually publish the key or the fingerprint of the key, which makes it hard for the user to actually understand what's happening, because you have to understand what the fingerprint is, stuff like that. But it was good enough for us to use in the domain manager. Also in the Keyman prototype, you only had certificates to log in. So we decided to keep the certificate login to raise the security level from just using passwords to something more secure. So you can log in with the certificate, and then you have exactly the same type of user interface. So this is an example with the fingerprints and everything. You can look at all the keys and see what the key is, if it has the SCP flag set or not, and what kind of algorithms is used. So this will probably never be user-friendly. And this user interface is also only for name server operators that are separate from the registrar. So most registrar probably want or need an interface like this if they want to accept keys from other name server operators. Other interfaces that we needed to modify was the EPP. We used the standard EPP DNSSEC extension. I think you probably all use EPP in here. The only deviation from the standard DNSSEC extension we have is that we have the magic number 0. So if you use 0 as a key tag when removing keys, that means that you remove all the keys. And I have a key tag is something that you have for a key to just identify the key within the protocol and in user interfaces. But the key tag is basically only a 16-bit number fingerprint. And the key tag algorithm is quite bad, because if you use RSA SHA-1 keys, that hash is basically just using a third or fourth of the available bits. So, but I have generated a huge number of keys, so I have seen that if you use RSA SHA-1, you cannot produce any key tag with the magic number 0. So that seems to work. We also had no email interface before we actually removed that for the resellers. That was removed, I think it was last year. And we have an extension to Whois that just says that this a domain has a secure delegation or not. This is an example from Lupia, what they have done with the DNSSEC. They don't have the possibility to let other name server operators to send keys through the registrar and up to .se. They only have a service where you can buy DNSSEC. I think they have a one-time cost when you buy the service from them. What they do is just sign the domain and handle everything about DNSSEC themselves. So the customer doesn't know what's happening at all. I don't think he never sees the keys. But this is only for domains that they are running name servers for. And I think this is the simplest way to do DNSSEC. Other projects we are currently looking at is how you want to send DS records to the parent. This is something the TLD community within the ITF have talked a lot about, but we need to involve registrars in this process because most very large registrars has their own user interfaces or APIs for their customers. But if we want to have tools that are general, such as OpenDNSSEC, we need interfaces to just integrate with any registrar to just send keys to the parent. We're also looking at how we can handle the transition from NSEC to NSEC 3. I don't think it's anytime soon, but we need for OpenDNSSEC to handle it anyway. Most people today are just launching NSEC 3 anyway. Within OpenDNSSEC, we are also going to standardize a lot of the APIs and parameters so that you have comparable parameter names and what they mean in other tools as well. Because if you look at the different tools today, and when someone says jitter or any type of parameter, it doesn't mean the same thing always. We have also been looking a lot on how you can use DNS for storing different kind of crypto material. Rickard has been working with DKIM and how to store DKIM keys in DNS. In order to do that in applications, you actually have to have the resolver very close to or within the application. The Czech registry has produced a DNSSEC plugin for Firefox. So I think that DNSSEC is going to move into the applications in order to secure DNS all the way to the application. And we also have the mess with transfers. In .se, we have a requirement on all the registrars to be able to at least remove the DNS keys for a domain. And we have seen that, especially since the launch of the registrar model, that some of the registrars has a lot of DNSSEC customers, and when they started moving away to other registrars doing a transfer, they just started to use new name servers, but they still had the DNS key available, which means that for a lot of customers it didn't work at all because the new name server operator didn't keep any of the old DNSSEC stuff. So that validation failed for all the secure validators out there. So we need to have a standardized way of actually doing transfers between, at least if the customers want to have DNSSEC between the different registrars and different name servers. So that's one thing that we see as a big problem right now. So what we have done right now is that we have replaced the current signer with the new OpenDNSSEC. So we have the new signer in place that looks exactly the same from the outside. It just fetches the zone with SSH and sends it back with SSH. But the new thing is that we're using a real HSM, which is Sun SAA 6000. So Rickard is going to talk a little bit about HSMs today as well. But we also have to keep the smart card interface because we still have the old KSK on the smart card. At the end of the year, we're going to remove the smart card at the same time when we're removing the key, so we don't have any dependency on the smart card anymore. We have a duplicate all these computers at the backup facility, so if something breaks, we can fall over to the backup facility. Oh.
The keys in the HSM when you replace the smart cards?
All new keys are stored in the HSM. We actually have the old ZSK also available using soft HSM in the same machine, but that's going to be replaced just within a few weeks. All right. That's how we as a TLD handle DNSSEC right now.